Well, thank you guys so much for joining the Math Information Session. My name is Maisie Morcera. I'm the interim undergraduate advisor for math until August, and then Bryant will be back. So thank you all for joining. We have a great sized group here. But I do want to give a warm welcome and thank you to our three professors, Dr. J.F. Williams, Dr. Michael Monagan, and Dr. Tamon. So thank you all for joining. We will start with Dr. Williams.
Okay, so this is our info session to try to explain to you why you might want to do a math degree if you haven't decided to do one already, and also to explain a little bit about the ins and outs of our different programs, some of the opportunities that you would have as a math student that you may not be aware of, and also give you kind of a heads up about how to get through the whole thing. Okay, so today we're going to talk about why would you study math in the first place, and what our programs are, and then at the end we'll talk about admission. We generally try to be pretty open about admission, but at the same time we don't want to admit students who we don't think are very likely to be successful, which is obviously none of you. Okay, so why would you study math? Most people go to university in this day and age because they're thinking about their future life, right? So you're thinking, what are the kinds of jobs that you can get? And math prepares you for pretty much any quantitative career, right? Because mathematics really covers the foundations of the technology used in all these different areas. And so if you've studied mathematics, you are well prepared to do all of these types of things. And also other things that are coming down the pipe, right? I mean, a few years ago, there wasn't this notion of data science, but everyone who was able to do mathematics at a certain level was able to start moving in that particular direction of data science, because these technologies and these ways of looking at the world are really based on mathematics and mathematical ideas and the kinds of tools that you learn as an undergraduate. There are an awful lot of great job prospects as a math student. Every time they do one of these studies looking at college majors in the US or career rankings, math always comes out very, very near the top. Similarly, if you look at admissions into law school or med school, students from math do very well when they apply into those types of programs, perhaps surprisingly. When you might not think that that's a good preparation, but the kind of logical thinking, problem solving, tenacity, all of those types of skills are very helpful in a wide variety of areas, whether or not you're using your math directly or not, right? And it is really a growth kind of area because we live in the age of data, we live in the age of computers, and so understanding all the technology and the ways that that's built can really prepare you for a whole wide variety of different future job opportunities. When you look at what students that have studied math do, well, a lot of them stick around at the university and they might do a graduate degree, and so you see a lot of them doing either, say, teaching or research assistant. That's really the first job for many students who remain at university, right? They go on to graduate school. There's a whole generic category of analyst in this day and age, which really means you look at information and you try to make sense of it. And the most sensible way to do that is quantitatively, to use your mathematical skills for understanding any of that kind of information. Lots of people from math go on to do software development, to do data analysis, to go into actuarial studies. I have 3 graduate students who went on to become actuaries because that training is very much helping you in those kinds of areas, right? So it isn't just that the only opportunity, if you've done a math degree, is to become a mathematician. I think it's on the order of 10% of people who do a math degree go on to be a mathematician at some later stage, whatever that mathematician happens to mean. So there's a whole wide variety of things you could do with this kind of a degree. Lots of our alumni, this is just from a survey from a few years ago, have been working in a wide variety of areas. For Google, for Aon Hewitt is a big fintech or financial services company. We have lots of people that work in the finance area or else do business analytics like TELUS or other places. Some people like math so much they want to teach it, and they go on to teach it in high school. we don't have enough teachers in high school who are good at math. So, that's always a good thing to be thinking about, right? And we have some students who go on to do a PhD and stay in the kind of the education space, because that's what they decided that they really love, right? So you really have a wide variety of things, and you should really think of a math degree as preparing you for anything that uses numbers in any kind of capacity, right? Or that can harness the kind of logical thinking that we really try and teach you very carefully. When you're one of the students in our department, there's lots of things you can do outside of the classroom. Obviously, we host the Putnam competition every year, so students write absolutely impossible questions, right? So the mode score, or the most common score on this competition, is 0, right? Most people get 0. That's the score more common than any other. So it's hard, but it's fun to put yourself through this. We have lots of students who do summer answer research projects, one-on-one with a professor or part of their research group in general. These are always posted in the spring around this time. If you look on the math department website, you'll find the ones that have been offered for this summer. It's too late to apply now, but you could just get a sense of what those things are for next year. And typical kinds of things are working with the BCCDC, not surprisingly at the moment, right, on looking at models and algorithms for outbreaks of disease. Looking at fluid mechanics of the weather, looking at certain kinds of combinatorial problems. These are all very kind of common things. We have people that do pretty much anything in the entire spectrum of mathematics with their undergraduate students, right? We have people who have undergrad research students who work on very pure theorems, whereas we also have people who do modeling the weather or modeling disease outbreak, which is very much at the kind of much more applied end of the spectrum. So there's really something for everyone once you get to that kind of level. SFU is a very strong co-op school, right? So there are always going to be lots of co-op opportunities. And again, they really run the gamut between technology, like Samsung or Motorola, through more kind of modeling or analytics areas like working with St. Paul's. I've had several students do work at St. Paul's in the past. We also have lots of finance, Scotiabank, insurance, and so on. And so again, there's lots of places where you can work as a co-op student and really see how your numeracy skills really help prepare you for a whole wide variety of different jobs once you leave the university. Within the department, we have a variety of programs. There's the math major and honors programs and the applied math major and honors programs. I'll talk about those in a minute. We have an operations research program, again, both major and honors, which I think Tamon will be talking about. And then we have a minor. We've worked very hard to make sure that our classes are accessible to minor students. We have a whole suite of classes that are specifically designed to give minor students some exposure to the breadth of mathematical classes. These are 301, 2, 3, and 4, which don't have necessarily fixed topics, but are really just drawn from the breadth of mathematical opportunities to give you a sense of the different things you could do without having to take the most hardcore proof-laden classes in order to get your minor's degree. You're welcome to do that, of course, but there's other ways to enjoy your math studies. We also have a lot of joint programs. So MACM is probably our most well-known, and these are students that are interested in both mathematics and computing and the mathematics of computing in a certain kind of way. Data science is a program that's fairly new and you've probably heard a lot about, that is joint with statistics and some other departments. And then there's the mathematical physics program, which is an honors only program, and that's run by the physics department. But those students take an awful lot of math classes. And that has 2 streams at the upper division, a physics stream and a math stream. And so you can do a very heavy mathematical physics degree if that's really where your interests lie. Okay, so let me just say a little bit about the programs and a couple of comments beyond these particular things. The next set of slides don't necessarily reflect the opinions of the math department. They're more my own. So there's also personal reasons why you would do a math degree, right? A lot of people think about their undergraduate degree only in terms of the job, the future opportunities. But at the end of the day, it's really a good time for you to kind of explore the things you're good at and the things that you love. right? And so you should also really be thinking about, you should do a math degree because you love math, or you should do a math degree because you're great at math. You don't have to love it and be great at it. It helps if you're both, but you have to be at least one, right, of those two things. So we often have a lot of students who really love it and just really enjoy doing it. And that's, that's your time to grow as a young person. And so that's an opportunity you should take advantage of, perhaps. And a lot of other students kind of liked math in high school. They get to university and they imagine there must be something more, and there really is. And this is, again, another opportunity for you to realize that, right? So you shouldn't only be thinking about what am I going to do next, right? But you should really take advantage of the things that you like doing, because once you leave university, the difference between a stats degree and an OR degree and a pure math degree, to anyone outside the university, they're pretty much all the same. It's also about how much you love what you're doing when you're doing it, right? So you should put some time into thinking about that too. So, but if you're at SFU, why should you study it, right? So what's special about our department, in and above just doing math in general? It's a very friendly department. I've had many experiences across campus, and I would say, we're a very friendly and helpful place. We have a lot of supports for students to learn, both in terms of the drop-in workshops and tutorials, but we also have very good advising, right? Because it can be very complicated to navigate your way through some of the programs. And we really put a lot of effort into making sure that you are able to make the right choices, to take the right classes at the right times. We have relatively simple and flexible programs, and we have pretty reliable scheduling. We don't require you to take 140 specified credits in order to graduate, but there's a lot of opportunity for you to take the classes that are of most interest to you, with a small number that are fixed, relatively speaking. Lots of co-op. If you're new to the university, you might imagine that math classes are gigantic, because that's all you've ever seen. Only at the beginning, right? The size and structure of the number of students in a math class is very much of a pyramid. And the farther along you get, the smaller and more personal they are, and the more opportunities you have to meet the other students, to meet the faculty, to get to know people, these types of things. And as I mentioned before, there are lots of research opportunities. As long as you know that they're there and you choose to take advantage of them, you really have a chance to do that with us. Okay, so the two programs that I'm going to talk about today are the math and applied math programs. And I'm going to skip over the slides that were generated, because I just kind of want to give you an overview of how these things are organized. At the lower division, there's a common core that is the same primarily in both classes. You take some calculus, at least three classes in calculus. You learn some linear algebra. You take some introductory analysis, and you learn a bit about computing. That sets you up to then do different things at the upper division. The math degree gives you more opportunities to take more classes in algebra and discrete math, and also in applications of those things, right? So the word applied math in this context can be a bit confusing. At the upper division, the applied math program has more continuous modeling, more scientific computing, again, kind of continuous, and perhaps a bit more analysis of different kinds. It's really a question of what you personally prefer and what you feel that is more of interest to you, which faculty you like better, right? I mean, maybe you decide you really want to take every class you possibly can with Professor Monagan, and so that leads you in a particular direction. That's fine. At this kind of level, it's really good to just enjoy what you're doing, right? There really are very, very many overlaps between the two programs. I've seen many honors students whose programs could have got them through either degree. It was just their preference as to whether they said they had a math degree or an applied math degree. It was really up to them. These are the course requirements, and they look really quite painful, but they're not. There's something missing off the math side on the left, which is 6 credits of science. You can do any 6 credits of science you happen to like. At the moment, the applied math program requires physics. That is changing as of September. It will require the same as in math, 6 credits of science. If you have gone through your first 2 years and decide you're in the wrong program, there are at most 2 classes you would need to take to meet the requirements for the other program. If you've gone through math, you may not have taken Math 252 or Math 260, but you'd have all of the other lower division requirements for applied math. If you've gone through applied math, you might not, have the lower division requirements of MACM 201 and MACM 101 for the math program, but you would have everything else. So they really are very easy to move between if you decide later, oh, that's actually what I really want to do next. That's really what I understand. And again, they are quite flexible beyond that point, because it may look like a lot of requirements for either one of these programs, but really they're very clearly laid out. There's a few classes you must take. There's a few classes from different regions you have to take, but generally you have a lot of flexibility to choose the classes you're most interested in. The math program has a nice requirement of some algebra, one discrete math class, one analysis class, one algebra class, one applied math class. So it forces you to have some breadth. The applied math program says, here's a suite of classes that we think everyone that does applied math must know, and then you can fill in the remainder more or less as you please. So both of these two programs give you a lot of choice as to what you can take and what you can skip, because you may decide there are certain areas you just really want not to do any more of, and that's perfectly fine, because there's a whole wide variety of ways you could fill those programs in, or rather fill the rest of your classes in for those programs. So I'm now going to toss it over to Professor Stephen to talk about the operations research program. And so I will stop that. Thank you.
Terrific, thank you. All right, so I'm talking very briefly about the operations research program. You can think of operations research as, in some sense, the mathematics that treats large-scale problems that arise in modern planning and decision-making. In some sense, I'll say we look at problems where you can't really fit them on a single piece of paper. They tend to come with a lot of data. We emphasize quite a bit on modeling. Let me just try to give you an example of the kind of things that we think about. In particular, maybe I could highlight supply chain management as something that has been quite interesting. Let's say in the past year with COVID, we had all these crises with PPE, and now we're trying to distribute vaccines at a very large level. So all of those have to do with supply chains, which are very complicated. They're not like a calculus problem. They have 1,000 moving parts, and we need to sort of put them into a spreadsheet, let's say, and understand them in a useful way. And this stuff is certainly very important. So the question is, how do you think about this mathematically? It's different, as I say, than some of the things you may have seen before. It's not always called operations research. I'll say that some of the things we do, you might see under the heading analytics, big data, data science, logistics, optimization. All of these things are closely related. I might mention, so I teach in my intro to OR class a lot of data science majors, and I think some of you may be interested in that program as well. Maybe I can say that, in some sense, one might ask, what's the difference between data science and operations research? I'll say that our data science program, for instance, focuses a lot on learning a bunch of different tools that are certainly great to have on your CV. Operations research, in some sense, is really focusing on the ideas that are behind these. So I think certainly that the OR program lets you approach these kind of problems in a way that really promotes sort of a deeper understanding of them. I sort of personally advocate it, studying the ideas and then picking up the tools sort of as you need them and as they change as well. I'd like to mention, you've probably seen the traveling salesman problem in various guises. In some sense, this is really a touchstone OR program. It's mentioned in a few of our courses. So the idea is, let's say I give you a list of cities. Here we have, I think, I guess, a selection of cities in the US, and we ask ourselves what's the best way to visit each of the cities exactly once. Let's say in terms of distance traveled or time or fuel expense. Again, this is a problem. I mean, I have a picture here, but to actually write out all the data, it does not fit in your page. You need a big computer program to even start talking about it. And the question of how you can first find a good tour and then show that it's actually the best tour really involves a ton of beautiful mathematics, which we would like to teach you. Yeah, so it comes up in the OR program. I can mention also that our OR courses, because we're working on these big problems that maybe are not so not suited to your 8.5 by 11 piece of paper, pencil and paper test. We do projects in some of our courses. In particular, the Introduction to Operations Research Math 208W features kind of a small project where we just sort of tried to think about where we get data from, how we can use it in optimization, then do a little bit of optimization. The OR program also features a capstone course, Math 402W, which is where the students do fairly realistic projects. We often enter them into the Canadian OR Society's competition, and they do really well. Topics have included, for instance, nurse scheduling, this school bus routing, setting tolling levels on the bridges in the Fraser River, queuing network for refugees. This term we had a group work with the city of Port Coquitlam a bit to discuss how they route their waste. These are very interesting, very nice projects. As I say, they've also received national recognition. These are, I guess, well, so on the left is a group that won first prize nationally in 2018. In 2014, we actually had 3 of the 4 finalists at the competition in Ottawa. And so this is representatives of 3 groups, including the winners. Yeah, we'd love to recruit some more students for this and continue to do well. CORS, the society I mentioned, offers a diploma, which you can get through our program. Well, so there's the usual list of courses, which is available on the web, and I'm happy to talk to you about. I can really emphasize Math 208W as a very interesting starting point, where you'll get to sort of do projects and longer assignments that I think are very interesting, different from what you've been learning in calculus, and sort of get you a feel for what you'd like. It's also a gateway into data science as well. So if you're interested, then I'll expect to see you there. Either way, but great to take it sooner or later. Among the other courses, I can mention Math 348 is a very interesting course that's only offered once every 2 years, and it's going to be offered in the fall. It, in some sense, teaches you things like queuing theory that are of interest in many of these problems. And I think that is it for me. So I will end my share.
Thank you. Thanks, Tamon. Now on to Dr. Monagan.
So good afternoon. My name is Michael Monagan. I'm one of the professors in the mathematics department, and I'm presenting the MACM major and honors program. And after that, I'm going to say something about the minor in mathematics program, and then something about the honors programs in mathematics. So starting with the mathematics and computing science program, the MACM program, Why would you want to do the MACM program? There's 4 reasons there. The first one's kind of an obvious reason. You like math and you like computing and you're good at both of them. So that's a good reason to do this program. It's a joint program in mathematics and in computer science. And there's 3 other specific reasons there that I'd like to speak to. The first one is as a personal reason. When I went to grad school in computer science, my math background was not very good. And I regretted not taking more math courses when I was a computing major. I got actually sucked into doing all the neat computing courses at the expense of my math skills, and I regret it. And not all the computing courses were that neat. So if you are thinking of going to grad school, you're a computing major, and you're thinking you might want to go to grad school, depending on the subject area in computer science, you would be advised to do more math courses. And one way to do that is to do the MACM program. For example, I wrote down this list. These disciplines in computing are highly mathematical: machine learning, computer graphics, computer vision, cryptography, theory of computation, my particular research area, symbolic computation, computational biology. There's a lot of them. There's a lot of sub-disciplines in computing that are highly mathematical. And if you wanted to go to grad school in one of those areas, you'd be better off doing something like this, a joint degree in math and computing. The second reason there is for math students. If you're a math major and you want to go and work in industry, you're probably going to use your math skills on a computer. So it would be beneficial to have a strong computing component to your degree as well. And another reason, if you're a math major and you want to go on to grad school in math and you want to do math research, then an increasing amount of mathematics research is now done on a computer. So it would really help if you had good computing skills for that as well. So that's some reasons for doing the MACM major. I have here a list of the lower division requirements for the MACM major. And it's there because I want to point out the following. If you are currently doing a math major and you're thinking of maybe switching to doing the MACM major, then there's only 2 computing courses at the lower division that you would need to do in addition to your math lower division requirements. And those are the 2 courses in blue, Computing 225 and Computing 295. So if you want to make the switch from math to MACM, there's only 2 computing courses that are not already in the math lower division requirements. And I would just suggest that you do Computing 225 as soon as possible for 2 reasons. One is it's a prerequisite for many upper division computing courses. So you'd want to do it quickly so you can take upper division computing courses. The other reason is if you're really not sure whether you want to do computing, you're a math major and you're not sure if you want to get into computing, it's a good course to find out if you really want to do both. The 2 red courses there, if you're a computing major and you're thinking of doing the MACM major, computing and math, the 2 red courses are the only math courses that you haven't done. You've done all the other courses in your computing major for your computing lower division requirements. And Math 242, the analysis course, and Math 251, the multivariate calculus course. Those are the only 2 additional courses that you would need to do. So it's easy to make the switch. This is a list of the upper division requirements for the MACM major. I'm just going to go through it, and just to illustrate the flexibility that you have. The program is very flexible. There's not a large core requirement that you have to do, as there is in the computing major, for example. So in the MACM major, you have to do 1 course in algorithms and data structures, 1 course in scientific computing. I'm calling it scientific computing because it's a nicer name for the course, and 1 algebra course. And then you have to additionally do 1 systems course in computer science, and you have to do 1 additional math course where you have a selection. So these these courses in this block and this block are courses that are core for MACM students. They use math and computing, so they are listed there. So that's 5 courses, and then everything else is an elective. You have to do in total 21 upper division math credits plus 24 upper division computing credits. So the total is 45 upper division credits. So that's the requirements for the MACM major. There is also a MACM honors degree program. I'm not listing the requirements here, but I'd just like to point out that there is the option, if you're doing the honors degree program, to do a research project. You can do the research project, the honors research project, in math or in computer science. And it's an opportunity to work with a professor on a research problem. Something else that's maybe relevant, some of you might not be sure whether you want to, you're doing a math major and you're not really sure if you want to switch to the MACM major, but you know that you should do some more computing courses. There's an option to do a computing minor, so a math major and a computing minor, that's an option. And of course, there's an option to do it the other way around. You can be doing a computing major and you'd be interested in also doing a math minor. I'm going to talk about the math minor now. What's the math minor? Here's some reasons to do a math minor. The first reason is it's really easy in the sense that you don't have to do a whole lot of courses, and you've probably done quite a few of them already. It requires 9 courses, 27 credits. As I'm going to show you in a moment, there's no restriction on the upper division courses. You can choose any upper division courses, so it's very flexible in terms of the actual courses you choose. It fits well with most undergraduate degrees. I'm going to explain that in a moment. And it adds a quantitative designation to your transcript that may set you apart from other students in your area. I think the next 2 points have already been said. So here's the requirements for the math minor, 9 courses in total. There's 4 lower division courses, the first 2 calculus courses. Many of you will have already done them. Linear algebra, and 1 additional math or MACM lower division course. Many students do Math 251, the multivariate calculus course, or MACM 201, the second discrete math courses. So there's 4 lower division required courses, and then you have to do 5 upper division courses, and they can be any math or MACM courses. So you're completely flexible in your choice there. There is one restriction, namely you can't double count a course. So if a math course is required in your computing major, you can't count it twice. You can't count it for the computing major and for the math minor. How does the math minor fit in your university degree? This is a broad overview. The requirement for a major at SFU is you have to do 120 credits in total for the degree. And in science, in the science faculty, 44 of those, how do I get rid of that? There we go. 44 of those credits have to be upper division, and in other faculties, it's 45 upper division credits are required. Most majors at SFU are 30 credits or 33 credits, somewhere in the low 30s. So you can fit the minor requirement, which is 14 or 15 credits, together with a major requirement to make up the upper division requirements for your degree. Something special that our department is doing for the students who are doing minors, and we have a lot of them. I think at one point we had over 200 students who are doing a minor in math together with their major in statistics or computing or economics, is these courses which are called mathematical journeys. And These courses have a low prerequisite requirement so that it's easy for, if you're doing a minor, you don't have to have done a lot of courses to get into them. And they're meant to be fun courses that are exploratory, and they use math and maybe a little bit of computing. Some of them have a little bit of computing involved. I'm just going to share with you 4 of these courses so you get an idea of what these courses can be. We offer one of these courses each fall and each spring semester, and they're targeted towards the math minor students. So this was a course that Jamie Mulholland offered on permutation puzzles, on puzzles and games. And you can see Rubik's Cube at the bottom. And of course, you learn how to solve Rubik's Cube, but the focus is on the group that's involved in Rubik's Cube, the group theory concept of a group. This is a course on geometry and symmetry offered by Matt DeVos that includes fractals. This is a course offered by John Starkey, was offered by John Starkey on the mathematics of sport. And this is an older course that was offered on set theory, I think by Veso Jungchich. Okay, so that's it for the math minor. What about honors programs? So the department, you've already seen 2 honors programs, actually 3, the mathematics honors program, the applied math honors program, and the operations research honors program. So the department offers those programs within the department, and then there's some joint programs with other departments. The mathematics and the MACM major and honors, the MACM honors program, which is this first one here. The data science honors program that Tamon mentioned, and the mathematical physics honors program that JF mentioned. So we have honors programs. What is an honors program? What do you have to do to get an honors degree? It's now the same number of credits, so it's 120 credits. The main difference is instead of doing 45 upper division credits, you have to do 60, a minimum of 60 upper division credits. And the other main difference is that you have to have a GPA of 3.0 to get an honors degree. And in our department, we are trying to give students who are doing an honors degree, either requiring them to do a research project or encouraging them to do a research project. So for math and applied math, you have to do the research project I'm going to mention in a moment. For operations research, you don't, but in operations research, as Tamon just mentioned, there is a project. It's Math 402, which really fulfills the role of doing a research project. So in math and applied math and OR, you can do this research project. So what is it? It's a 1 semester research project. It's 6 credits in total, and you would be working with a faculty member. And what you will do is you will do some research, and then you will write up a research report in LaTeX of approximately 25 pages in length. And then you will give an oral presentation of the research project, a 25-minute presentation. And the mark for the course will be based on the report and the presentation. And if I remember correctly, it's 75% of the mark is on the report and 25% of the mark is on the presentation. And in order to prepare you to do this, we have this 1 credit course. It's a 1 credit course. You meet once a week for, I think, an hour and a half, and you learn how to do research. You learn how to write a research report, and you learn how to give a talk in this research project. And I'm just going to read what's written down here because it's carefully thought through. A research project can help you decide if graduate school is an appropriate path for you. If you're not sure whether you want to do research, you want to go on to graduate school, if you do a research project, you'll get a good idea of what research at grad school will be like. And doing well is a strong predictor for graduate school success. I would also add that when professors like me are looking for which students to take on as graduate students, we look at your undergraduate transcript and see how well you did overall, what your GPA is, but we would also be looking to see if you've done a research project, because if you have done a research project, and you did well, then we know that you're well prepared for doing research. And so we're much more likely to pick you because you've done that. One final slide for the honors program in mathematics. We've designed it so that you can choose a focus, an area of focus or concentration from one of these three options. So when you do an honors degree in math, you would choose one of these three options: algebra and number theory, or discrete mathematics, or analysis and optimization. And then you would do a set of courses chosen from that area to focus on as part of your degree. I think that's the end of my presentation. I will leave my email up in case anyone wants to jot it down, or jot down my name in case you want to ask questions later.
Thank you, Dr. Monagan. It's going to be brief. I do want to point out our co-op resources for the department. We have Magnus Billings, who is our mathematics co-op coordinator. So always feel free to email him if you have any co-op questions regarding math. And once again, to be part of the math program, it will be considered an internal transfer. So please take a look at the internal transfer website on our math department website. And basically, we generally require you to finish all your lower division requirements, and then with at least a GPA of 2.0. If you have completed some upper division, we will factor those in as well. But and then for the honors, once again, it's a 3.0 GPA minimum that we're looking for. So, and down below is me and Bryant's email address, math_advice@sfu.ca. Once again, Bryant will be back in August, but as of right now, I will be your advisor until then. So thank you all for coming. I will stop sharing my screen and I will stop recording.